A wall of muddy water and debris suddenly tears through this mountain valley. Looking at these images, the obvious explanation is extreme rainfall somewhere upstream. But that is not what appears to have triggered this disaster. There was no extreme local rainstorm of the kind normally associated with a flash flood like this. Instead, investigators traced the beginning of the event much higher into the mountains. And at first, there seemed to be another explanation. Instruments detected seismic energy in the region, initially reported as an earthquake. But further analysis changed that picture. The USGS ultimately classified the signal as a magnitude 5.2 landslide. In other words, the seismic signal was not evidence that an earthquake had triggered the collapse. The collapsing mass itself was powerful enough to register seismically. That tells us how violent the initial event was, but it still leaves the biggest physical problem unanswered. A collapsing glacier gives you ice and rock. So, how did that become the enormous moving mass of water, mud, and debris seen far downstream? The source of that seismic signal was high above the flooded valley, at roughly 5,200 meters, about 17,000 feet above sea level. A section of the glacier broke away and dropped approximately 1,200 vertical meters before reaching the lower valley system. That height matters because once the ice and rock lost support, gravity began converting elevation into motion. The farther the mass fell, the more potential energy was released as speed and impact. That is the crucial energy source at the start of the chain, not a sudden input of rainwater, but a large mass losing height under gravity. The drop does not tell us exactly what happened later in the river, but it explains why the process began with so much mechanical energy. So the glacier collapse was not just a block of ice sliding slowly downhill. It was a high-energy mass movement traveling through extremely steep terrain, and that explains why the initial collapse could be powerful enough to generate a major seismic signal. But it still does not explain the footage downstream, because even after a 1,200-meter fall, the source material was still mainly ice and rock. The next problem is the one that matters most. Where did all that water, mud, and additional debris come from? If you like seeing the hidden physics behind extreme engineering and infrastructure, subscribe. That difference between what fell from the mountain and what appeared downstream is the key to understanding this disaster. It is tempting to imagine that the falling glacier simply melted and turned into floodwater. But the evidence does not support such a simple transformation. Researchers are still working out exactly where the enormous volume of water came from. Some could have come from the ice itself, while water already in the river and within wet sediment may also have contributed. The exact proportions are not yet known. That distinction matters. The question is not how one block of glacier became one block of floodwater. It is how an ice and rock avalanche entered a river corridor where water, saturated sediment, and loose debris were already available to interact with the moving mass. The important point is that the glacier did not enter an empty valley. It entered a physical system that already contained water and material that could become part of the moving flow. So the flood downstream was not simply the original glacier in liquid form. It was the result of a moving mass interacting with the environment around it. And that creates a much more important question. If a fast-moving mass encounters wet sediment and loose material on its way downhill, does it simply pass over it? Or can it pick that material up and become larger as it moves? A fast-moving flow does not necessarily leave the valley floor behind. As it moves across loose, wet sediment, it can erode material beneath it and pull that material into the moving mass. This process is called entrainment, and that changes the way we should picture the disaster. The material moving downstream does not have to be limited to whatever originally fell from the glacier. Once sediment, rocks, and water from the channel become incorporated, they move with the flow. Experiments by the USGS have shown that entrainment can increase a debris flow's volume, speed, and the distance it travels. So the valley is not just a surface the debris moves across. Under the right conditions, material in that valley can become part of the moving system itself. How much this process amplified this particular disaster is still being investigated. But the mechanism explains how a debris flow can change dramatically between where it begins and where it eventually arrives. And once that moving mass reached the river, another possibility appeared. The same debris being carried downstream may also have been capable of temporarily blocking the water's path. When that debris reached the river, it may have changed the flow in a second way. Preliminary satellite analysis indicates that avalanche debris temporarily blocked the river roughly 20 kilometers upstream of Materi Bridge. If that reconstruction is correct, the debris did not immediately continue downstream. For a short time, part of it acted like a natural dam. Water flowing from upstream would then have nowhere to go at its normal rate. It would begin accumulating behind the blockage, increasing the amount of water being temporarily stored. And unlike an engineered dam, this barrier would consist of loose ice, rock, and debris, rather than a structure designed to control water. Preliminary analysis suggests that the blockage eventually failed, allowing the stored water to move downstream again. That could have added another surge to an already complex mass movement. But researchers are still reconstructing the exact sequence, so this cannot yet be treated as the complete explanation for the disaster. And whether that temporary dam amplified the flood or not, the material arriving downstream had another property that mattered enormously. It was not behaving like water alone. That distinction matters because what arrived downstream was not behaving like water alone. A normal flood transfers force mainly through moving water. A debris flow carries large amounts of solid material inside that moving mass. Mud, sediment, rocks, and other debris are not simply floating on top. They move with the flow and become part of what strikes anything in its path. That changes the physical impact. A structure is no longer resisting only the pressure and momentum of flowing water. It can also be hit by dense sediment and large pieces of material carried within the flow. And those impacts can happen repeatedly as the debris continues moving downstream. This is why calling the event simply a flash flood misses part of the physics. The water was only one component of the moving hazard. By the time the flow reached infrastructure downstream, it had become something very different from the ice and rock that first started moving high above the valley. And that transformation is the key to understanding how one collapse in the mountains could affect places many kilometers away. That distance is what makes the event so easy to misunderstand. The destruction happened far downstream, but the physical chain began high above it. Seen from above, the connection becomes clearer. The glacier was the starting point, but the river valley provided a continuous pathway through which the event could travel and change. Gravity supplied the initial energy high in the mountains. Once the collapsing mass entered the drainage system, it was no longer an isolated block of ice and rock. It became part of a larger moving system involving the river, sediment, debris, and the terrain itself. That is the key to understanding what happened here. The valley was not just the place where the disaster occurred. It was part of the mechanism that transmitted it downstream. So, when a flood like this appears without the extreme local rainstorm people expect, the source may be far beyond the water they can see. In this case, understanding the flood means looking all the way back up the system, to the glacier, the enormous drop in elevation, and the connected valley that carried the consequences downstream.